Artificial intelligence has a physical problem. While the algorithms are getting smarter, the hardware they run on is hitting a wall. We are facing global compute shortages, skyrocketing centralized cloud costs, and data locked behind corporate silos. But what if the infrastructure for the next wave of AI wasn't owned by big tech, but by people like you? This is the DePIN revolution, the critical convergence where distributed ledger technology provides the physical body for the AI brain. Today, we are breaking down the essential foundation of the new economy, decentralized physical infrastructure networks. Before we talk more about autonomous agents or the future of digital commerce, we have to understand the nuts and bolts making it possible. This is DePIN Explained. This is educational content only, not financial advice. Crypto assets are high risk. You could lose all your money. Some description links may be affiliates. I may earn a commission at no extra cost to you. Always do your own research. To understand DePIN, we first have to look at the problem it solves. Historically, building a cell network or a cloud provider required a big tech monopoly approach. Companies spend billions up front to build massive data centers. Because they take all the risk, they keep all the control and all the profit. DePIN changes the math by using DLT to coordinate independent hardware owners. Individuals contribute their own GPU power, storage space, wireless hotspots, or sensors. This results in infrastructure that is cheaper to build and faster to scale. The DePIN sector has grown into a roughly $9 to $10 billion category with real, on-chain revenue. This involves businesses paying for tangible services like data storage and compute, moving DLT from speculation to real-world utility. How does a decentralized network actually grow without a central CEO? It's all about the DePIN Flywheel, a self-sustaining cycle of growth. It starts with an incentive. A new protocol offers tokens to hardware contributors. This attracts the supply as early adopters deploy hardware across the globe. As the network grows, it gains utility and becomes useful to developers. A mapping network isn't helpful with 10 cars, but it's revolutionary with 10,000. This creates demand as businesses seek cheaper, more resilient alternatives to big tech. Demand creates value for the token, which in turn attracts even more hardware owners. This cycle allows decentralized projects to do in months what used to take corporations a decade. The first major pillar of this revolution is compute. This is the brain of the digital economy. We are currently in a global compute squeeze driven by the explosive growth of AI. Companies are desperate for processing power to run their latest models. Projects like the Render Network and Akash are stepping in to fill the gap. Instead of waiting for a new data center to be built, these networks tap into GPUs in home offices and gaming rigs worldwide. By aggregating tens of thousands of GPUs through integrations like the Salad Network, these platforms provide the massive scale needed for AI inference tasks. This allows startups to perform AI operations for a fraction of traditional cloud costs, often saving 40 to 60% on their operational overhead. The second pillar is wireless, the pulse of the internet. The Helium network is a pioneer here, using a global community of independent providers to host hotspots that provide IoT and cellular data. But for a look at the industrial and social impact of this technology, we turn to World Mobile. Unlike traditional carriers that struggle to reach rural areas, World Mobile uses a hybrid model of aerostats, Starlink backhaul, and community-owned air nodes. This creates a sharing economy for connectivity, where local entrepreneurs earn rewards for providing internet access to their own communities. This grassroots approach is more resilient than legacy systems and puts the profits of the telecom industry back into the hands of the participants. This model proves that localized hardware can provide global coverage without the need for multi-billion-dollar towers on every corner. Next is storage, the memory of our digital world. Companies like Filecoin and Arweave provide a permanent, censorship-resistant alternative to traditional cloud drives. In a world where data privacy is a luxury, decentralized storage shards your files across hundreds of nodes. No single entity holds your entire file, and no central authority can easily turn off your access. This technology has matured into a key player in data availability for other DLT networks. It serves as a massive repository for the datasets required to train non-biased AI models, ensuring that the history of our digital world remains immutable. By removing the central point of failure, we ensure that the memory of our autonomous systems cannot be wiped or manipulated by a single provider. Finally, we have the eyes of the network, sensors and mapping. HiveMapper is leading the charge by incentivizing drivers to install specialized dashcams. They are mapping the world's roads in high definition with incredible frequency. This attracts significant interest from the logistics and automotive sectors. Every time a driver turns a corner, they are contributing to a living digital twin of the Earth. This creates decentralized data that reflects the physical world in real time, which is essential for the future of autonomous navigation and smart city planning. For an AI agent to navigate a city, it needs a real-time feed of physical obstacles and changes. DePIN sensors provide this high-fidelity vision that static, centralized maps simply cannot match. But how do we know the hardware is actually where people say it is? In DePIN, we use a concept called proof of physical work. Networks use cryptographic verification to ensure that hotspots are providing signal, that map data is authentic, and that a GPU actually completed its task correctly. This cryptographic layer is what makes DePIN different from a simple crowdsourcing app. It is trustless because the math proves the work was done. As DLT becomes the coordination layer for the physical world, the combination of DePIN and AI becomes the ultimate synergy. Modern AI models require massive compute for both training and ongoing inference. DePIN offers a globally distributed alternative that scales organically with participants, providing lower barriers to entry and strong resistance to censorship. An AI developer can access computing power across continents without a central middleman. Of course, maintaining consistent performance in a decentralized environment is a challenge. Issues around latency and variable hardware quality are still being actively addressed. Nevertheless, DePIN is becoming an increasingly practical solution for heavy workloads. AI delivers pattern recognition, while DLT supplies immutable audit trails. A promising area is on-chain inference, where AI model outputs are verified by the ledger. This enables greater confidence in results produced by potentially untrusted nodes. Imagine an AI agent making a financial trade. You need cryptographic proof that the agent followed its logic without being tampered with at the hardware level. Projects are leveraging Oracle networks like Chainlink to connect these AI computations to on-chain logic securely. Consider agentic AI, systems capable of reasoning and acting independently. These agents require always available infrastructure and secure payment interfaces. DePIN supplies the hardware backbone, while DLT manages the secure coordination. The Artificial Superintelligence Alliance, or ASI, remains a leading example of this collaborative ecosystem. A growing focus in this space is KYA, or Know Your Agent. KYA frameworks aim to establish verifiable profiles for autonomous AI systems, much like an ID card for an algorithm. This layer of accountability is essential for regulatory acceptance in high-stakes environments like healthcare or autonomous transport. Economically, the convergence is creating entirely new incentive models where hardware contributors are rewarded for supplying the compute that fuels innovation. However, we must acknowledge the broader limitations. Regulatory uncertainty regarding cross-border data flows will influence adoption. Enterprises remain cautious about mission-critical operations on decentralized systems because they require strict service-level agreements. Token price volatility can also impact the long-term stability of hardware participation. If the rewards drop, the hardware might go offline. Looking ahead, hybrid architectures appear to be the most promising path. DePIN will likely absorb overflow demand alongside established cloud systems, delivering greater accessibility and systemic resilience for the AI revolution. It acts as a safety valve for the centralized world. DePIN is the bridge between digital scarcity and our physical reality. When we talk about AI agents in our next video, remember these pillars. They need a brain to think, a pulse to communicate, a memory to learn, and eyes to see. DePIN provides all of it. We are moving away from big tech monopolies toward a people-powered economy where the very machines that run our world are owned by the community. For those of us watching the pulse of the market, this is only the beginning of a multi-decade shift in how we build and interact with infrastructure. Check the description for resources on the projects mentioned today, including the primary source white papers for Render and Filecoin. Thanks for watching Crypto Pulse 360. Stay pulsed.